Assalamu alaikum. Welcome to my channel M.Asif Math Corner. Today we will study about what is factor group or what is quotient group. It is same thing, factor group and quotient group. So let's start. The definition of factor group or quotient group is let H be a normal subgroup of G. Normal means that if we have H is equal to G H G inverse. This is definition of normal subgroup where this small h belongs to a H which is subgroup of G and this G belongs to capital G. This G is also group and this H is a subset or subgroup of G. So this condition tells us that it is a normal subgroup. You can write it like this. Thus H is equal to G H G inverse where G belongs to G, or you may write this GH is equal to HG. These are self conjugate. You can say it as self conjugate, or this is also definition of normal subgroup. This type of elements makes a group which is called normal subgroup of G. And consider a collection Q of all left cosets. I will give in the description the link of my video left and right coset, what are left and right cosets. You can see that video. I hope you will understood complete about left cosets, what are right cosets. Shortly I want to tell you that what are left cosets. If we have a group G which is equal to 1, 3, 5, 7 and we have a subgroup H is equal to 1 and 5, we multiply all the elements of G one by one from left side. 1 into 1 1 and 1 into 5 5. This gives us first left coset. Similarly, when we multiply 5 multiplied by 1, it gives us 5, and 5 multiplied by 5, it gives us 25, and this group is residue classes of 8 with respect to multiplication. So 25 give us, when we divide 25 by 8, it gives us 1. So these are two left cosets, and all the collection of these left cosets makes a group or collection which is called Q, and this Q is called quotient or factor group. So we denote it like this. Q is equal to G by H, where H is a normal subgroup, and all the collection of left cosets of H are equal to Q, and A belongs to G, is called the factor group by G by H. Define a multiplication in Q is like this. The two left cosets, when we multiply two left cosets, it gives us again a left coset. So this left coset also belongs to Q. If these two left cosets belongs to Q, then its multiplication also belongs to Q. Hence Q is closed. We have a theorem. Prove that a factor group Q G by H, all left cosets of G and H form a group. So we have to prove that this collection is a group. So for proving that it is a group, we need to prove its all four properties: that it should be closed, and it should hold associative law. Identity must exist, and inverse of each element also exist in this. So since factor group, as we defined earlier, that Q is equal to G by H, where what is Q? Q is collection of all left cosets of G in H. We define a multiplication in Q, that this is the first left coset and this is a second left coset. When we multiply these both left cosets, we have again a left coset which also belongs to Q. If first left coset belongs to Q, second left coset belongs to Q, then its multiplication also belongs to Q. You can see by this example that 1, 3, 5 and 7, we have two left cosets here. One, when H is a subgroup of G and this is equal to 5, and we are going to take first left coset 1 multiplied by H. It gives us 1 into 1, 1, and 1 into 3, 3. This is first left coset, and I am going to write here second right coset multiply 5 multiplied by H. So it will be equal to, when with this 5 multiplied by 1, it gives us 5. When we multiply this 5 with 5, it gives us 25. But we have taken a group of modulo 8 residue classes with respect to multiplication. So we will divide, if we get the number greater than 8, we will divide it by 8. 8 4 times 24 and remainder is 1. So this is the residue group of residue classes. 1 will be here. So it is 1 5. When we multiply these two left cosets, this and this, so 1 multiply 5, 5, 1 multiply 1, 1, 3 multiply 5, 15. 15 means when we divide 15 by 8, it gives us 7. So we know that 7 is also belongs to G. And 3 multiplied by 1, it gives us 3. And 1 multiplied by 1, it gives us 1. So it's mean that it makes an other left coset of G in H. So first we check the multiplication is well defined. For well defined, we multiply first left coset by left coset, and here you can see that H1b, we can change its order because we have told that H is a normal subgroup. So if it is a normal subgroup, this is the definition of normal subgroup, we can change its order. So H, here is H1, H3. So you can write this H3 is H1, and when AB multiplied by H1, H2 or H3, these are only identification names. So when we multiply two elements of H, because H is a group, it gives us an other element which also belongs to H. You may say that it is H4. So AB H4 belongs to ABH, which is the left coset of H. So here we have told that H4 is equal to H3 multiplied by H2, because H is a group, so it is closed. When we multiply its two elements, it gives us another element which also belongs to this H. Hence this is proved that it is a closed or well defined. Closed means well defined. So AB AH first left coset B dot BH, when we multiply these two left coset, it gives us again left coset. Hence multiplication is well defined. Now we have to show that Q form a group. Now we have to apply all four properties. We have proved that it is well defined or closed. So Q is closed. First property is clear. Second is Q is associative. So apply all three, take three left cosets AH dot BH dot CH. So we know that two left cosets make another left coset. By these two we get ABH, it is a left coset, and now we have two left coset. Again applying that formula we get again a left coset. So now separate it A from BC by reverse process. So AH dot BCH, again we will divide BC into BH and CH by reversing. So here we proved that AH dot BH dot CH by changing its brackets, we proved that it is associative law hold. And next is identity. H is the identity of Q because when we multiply an identity left coset with any other element left coset, for example AH into H, AH into identity EH, and this is left coset and this is also left coset. When we multiply two left coset, it gives us again a single left coset, and when we multiply AE, any element with identity element, that give us that element. So EAH is equal to AH. Similarly, when we apply here we apply from right side, here we apply from left side. H dot AH, here H is identity left coset, multiplied by any other element left coset. These two left cosets give us a single left coset, and this is equal to AH. Hence proved that identity element is also exist in quotient group. So the fourth and the last property is inverse. Inverse of every element must exist. As we know that H is a subgroup, a normal subgroup. So if A belongs to G, G is a group. So if A belongs to G, then A inverse also belongs to G. So let's take the inverses of, as I have given the example, 1, 3, 5, 7. So here inverse of 5 is 5, because when we multiply 5 by 5 it gives us 25, and when we divide it by 8 it gives us 1, which is identity element. It means that these three elements are self inverses here. So if we take a left coset of 3, then its inverse is also 3. The left coset of 3 is equal to of its inverse left coset. So inverse must exist, and we have left coset of inverse as well. When A multiply, A is the element, the left coset of A and left coset of its inverse. These are two separate left cosets, and we know that when we multiply two left coset, it gives us a single left coset, that is also coset of G in that group, H or any other. So A multiplied by A inverse, we know that when any element multiplied by its inverse, it gives us identity element. EH and EH is equal to H. Similarly, when we change its order, A inverse H is a left coset and AH is a left coset. When we multiply these left cosets, it gives us a single left coset, which is A into A inverse, and A into inverse is equal to identity. So it is equal to H again. It means that inverses of each element exist in quotient group. Hence Q contains the inverse of each left coset. Hence Q, G by H, or all the left coset of G and H, A belongs to G, form a group. I hope you understood. If you have any query or any question related to this, you may ask in comment section. Thank you so much.